Hello and welcome back to Azure Terraformer, coming to you live from Palm Beach, Florida. I'm trying something new. One of my fellow internet strangers has kindly submitted their code, their Terraform code, for review. So today I'll be looking through their Terraform project and just analyzing the code and giving some, feedback on it. So without further ado, let's look at this. I pulled this down from GitHub. And this particular internet stranger happens to be using folders for environments, dev, and prod, which is a technique that many use for long-lived environments. I tend to prefer using the same code base for dev and prod, and then altering that code base through variables, but I have seen this pattern, and it is a pretty common one out there. No problems there. Let's just look. I mean, it looks like these are stubs, so there's nothing in there right now, but surely they intend on using that. So this main module, I guess, might be where they would start deploying from. I guess this would be the root module. Looks like we're using OpenStack here. One thing that I always do, and of course this is a convention, but so it's not like a hard requirement or anything, but I tend to use main for critical keystone type resources, and I dump all my provider config into a separate file called providers, just to keep it all together, and so I know where to go, and it doesn't clutter up like those keystone resources or modules that I'm going to declare. So right off the bat, he's got required providers, which is good. And he's got a provider definition there. I would probably just go ahead and put that into providers.tf. So right off the bat, main is looking a little bit more juicy. We can see what's going on here. The reason why I dumped the providers in there is just it's boilerplate. It's got to be there. You've got to declare your providers, but when you think of main, or when I think of main as like the meat and potatoes. Like, what am I deploying? What are the critical things that I'm deploying? And so the providers are literally just like the conduit, that allows you to connect to whatever platform you're talking to. So that's kind of my frame of mind and my thinking behind why how I treat main and why I put providers into a separate providers file to keep them off by themselves. So one thing right off the bat is like there's some white space and formatting that I would probably clean up. Of course, I mean, I don't know what state this is in, but I'm a little bit OCD, so I'd probably make all my scrimmage lines, line up within the modules. I don't like checking in commented code, but I understand that this might be in flux. So, maybe these are just kind of temporarily there. I'm not sure why they're commented out. That's one of the big reasons, like why you shouldn't check in commented code. It's just, it may seem like a nitpick, but, when some other author is reviewing your code and they look at and they see stuff that's commented out, it immediately is like a red flag. Like, why is this here? Like, does this need to be here? Does this need to be here eventually? All these questions start popping up, and probably just means it's maybe not ready for a code review, or it shouldn't even be in there. It should be in like a feature branch or something that you're working on. But we'll give our friendly internet stranger a pass on that. I'm sure there's a good reason why that's the way that is. And right off the bat, I can see the pattern that is going on here is we have pretty much modules for everything, modules for everything. Don't get me wrong. I love modules, and I think modules are one of the most powerful things about the platform. But one of the core anti-patterns that I've found is that when you start seeing modules that are essentially just resource wrappers, and they add no value other than wrap the resource. I don't know if that's going on here, but we'll find out quickly. So let's go look at the network. That's the first one that we got here. So I just see one resource with a name and something set to true, and we're just outputting the ID. And we've got a required providers block, which is a good thing to do when you're defining a module. When you have decided, okay, I am going to go create a module, and this is how I'm going to set it up. You should absolutely set up a required providers block in your module and specify the version. Now, one thing I would want to point out here is, if we've agreed to create a module to do this thing, we probably don't want to use the squiggly arrow. The squiggly arrow basically targets a specific version of the provider, and most often for modules, you want to have a greater than or equal to sign on the module declaration. Why? Well, if you do a squiggly equals on your modules, then that means that you're limiting people that only use that specific version of the Terraform provider to be able to use your module. And that greatly limits your ability to use that module. And so you want to go use that module 3 months from now, boom, like you're gonna run into your Terraform init is gonna go try and get multiple versions of the OpenStack or whatever provider you're using, and you're gonna have provider conflicts, and it's gonna get nasty. So it's a good practice to use a greater than or equal sign on your modules, your reusable modules. On your root module, which I think our friend has set that up with the squiggly arrow, that's totally fine. On your root module, because your root module is an actual thing that you're going to deploy. A reusable module is more of like a library that you want to reference from a bunch of things that you're going to deploy. So big difference between a root module and a reusable module. So when you're structuring your modules, just make sure you think about that. But looking at network, just looking at the value that we're getting out of these 4 files, basically we just have a resource block. So I think this is one that I would file into. It's a resource wrapper, right? And in this case, we have hard-coded admin state up true. We're making this module even less flexible than the resource block itself. Now, that being said, I think there are cases where if there are repeatable patterns, some resources within providers are multimodal in that they can be configured this way or that way, and the resource itself has dozens of properties on it, and many of them are mutually exclusive. So in those cases, I think it's absolutely okay to hard code, this way or that way, how you want to use that resource. Just name the module accordingly. I'm not too familiar with OpenStack's provider here, but there doesn't seem to be a whole lot going on here. So from a sniff test, this seems like pretty much a resource wrapper, and I would probably just extract this out and dump this into its own TF file called network.tf, and then just drop it there. And then I would just kind of forget about this whole module business for the network. And then I can delete this thing right here. And of course, I need to take the network name and drop that, because that's no longer an input variable. It's just a constant. And we might want to bring these things over. They're commented out, so they're not really doing a whole lot, but they might be meaningful for some reasons. Okay, so now let's go look at floating IPs, and I'm gonna go look in here, and it looks like we got 2 resources now. Looks like a floating IP, which I'm assuming is kind of like a PIP, like a public IP address, or like that you can like pin and then associate to an instance or a VM, which seems pretty clear that that's what's happening here. Again, never use the OpenStack provider, so forgive me if I'm a little bit off here, but this seems like that's what's happening. Yeah, so looks like we have, I mean, I would classify this as a resource wrapper as well. I don't see a whole lot of value being encapsulated in this module, unless we're just talking about, hey, I've got 2 resources. It gives me a headache looking at 2 resources in my file. So I might just go snag those. And, these are related to the instance. I guess they're networking related. But maybe I'll just call this instances. But they are networking related, but really they're related to the instance, right? That's what we're getting here. So now let me go look at main. And is there anything really of value? Well, we do have this module with our instances. So I need to grab the that instance ID. It's no longer a variable. Was there a count or a for each on this? I can't remember. There's no count. So that's interesting. My pool, I'm just going to extract this stuff out. No longer a variable. Okay. Bada bing, bada boom. And we can delete that. And we can delete this. All right. Now let's leave DNS and instance for the end. Okay. Router. I hate to say it, this looks like a resource wrapper as well. Again, we got that squiggly arrow, so I'm just going to grab this. Router sounds like something specifically network related, so I'm going to drop that in here. I'm assuming we're just snagging the where did the router come from here? Router has not been declared. This router module has not yet been declared. Okay, so don't know what we're going to do with this yet. It looks like it's going to take a network ID. Maybe I jumped the gun here. I guess we do have this OpenStack network here. So I'm assuming the network ID is going to come from this thing, network.id. We'll have to read RTFM to verify that that's actually what's going on there. And the router name, of course, this thing hasn't been declared yet, so I don't really know what's going on there. But there's really not a lot of value of those 4 files. Now, again, the author, the original author of this may be in the middle of something. Maybe I'm oversimplifying. Maybe they have bigger plans for this stuff, but it seems like this is kind of resource wrapping going on here. Subnet, just one resource. We're just piping in some things and hard coding enable DHCP. I'm going to call this a resource wrapper, and I'm going to dump this into our network configuration here. And then we're going to do that. And I mean, you can tell you got a resource wrapper when you take one resource out and really we got some defaults embedded here. I would be really careful about defaults at the module level. I mean, be very thoughtful. I'm not saying like don't do it ever, but I mean in this case, I don't know. I mean that's Google's DNS server 88888. Maybe there's a good reason to do that, but be very thoughtful about when you set defaults, especially for reusable modules. It's almost always better to force the client, to specify value, unless again, of course, you are trying to add some opinionated nature to your module, where you're flipping the bit, so to speak, to have it go one way or another. Now, security group, let's go look at this guy. Security group, sec groups. Now inside here, we see Azure and AWS have an equivalent thing. This looks like we have a logical security group, which is basically like a logical structure that we can then associate rules to. And looks like we have two rules here, SSH and HTTP. I think this is actually a really good use case for a module, because nobody wants to just copy pasta these rules over and over again. It's just a bunch of yuck, and they're extremely common, right? So I like this. I think this has a solid use case for a module. What I don't like about it is we have some ports hard coded in here. So having those rules hard coded in there really limits the reusability of this going forward. So what we can do, and this is a technique, it's very common, like security groups. These security groups always have ingress and outgress, ingress, egress, inbound, outbound, whatever you want to call it. And so it's a very common thing. So what I tend to do is, what I'd like to see here is I'll go ahead and declare like maybe a variable called ingress, because that's what they call it, ingress rules. And I'm going to set the type to be maybe a list of object. And then on this object, what are we going to give it? Let's say let's grab some of these things, right? So we'll say, and so now that I've set up that variable, this variable here that's a list of ingress rules with Ethernet type, ether type, protocol, port, range, min and max, I can go restructure this, and I'll just go grab this, I'll go grab this out of here, and where I declare the security groups, I'm gonna say ingress rules, and it's gonna be an array. And the first object is gonna look like this. And then what I'll have to do inside my module is, I know the exact number of these, so I'm just gonna set this to be, this is for each trusted endpoint. So trusted endpoints is an array that we want to put on here. And we may need to go look at this up and see if there's... So looks like they're using these trusted IPs, and it's basically /32. So we have to create this rule for every /32 in this thing. So this gets a little trickier. Absolutely. Let's go look at that. So we're gonna need what was this, remote IP prefix? We'll just set that. We'll just add that to the contract, and that's gonna be a string. Actually, it doesn't look like the trusted endpoints is being used yet. It seems like these should all go into the same security group. So I'm just gonna go grab this security group's ID. I really see no reason why they need to be. There's not more than one security group. Yeah, this doesn't look right at all. This should not. I would not expect the security group ID to be pointing at the rules ID. That's kind of a circular reference. So I think that's broken. I could be wrong. But I think this is what we'd want to look at. This is what we want to see. All of these ingress rules that we're creating should be pointing at this security group up here that we declared, because we're going to attach it to that instance. And I guess we could additionally clean this up to make it a little bit less hard coded. But so I like this right now. But what we'd need to do is, for every remote prefix, we'd have to create a port mapping for. So if your work, your house, like your beach house, your cabin in the woods, every remote IP address that you want to have SSH or port 80 access, you'd have to add one of these rules for. Now we could do some work with collection functions to like make that easier on the outside. But I think from a consistency standpoint in the module, you give this module like a list of rules and of ingress rules, and it will generate them. This seems like the appropriate scoping of the responsibility of this module. Anything beyond that, like, should go outside, of that module, and whoever's calling that module should be responsible for figuring out how to pass in the appropriate rules. Okay, so let's go back. So I've got my security groups all set up here. These trusted endpoints, we would modify that to, whatever the remote prefix is. And I guess you could potentially just add. I mean, if it's going to be a CIDR, like, it looks like the resource wants a CIDR block, so 32 is a single IP address. You could pass in a /24 or whatever you want. But I mean, obviously, if it's your house, it's going to be your public IP address /WAC32. So then we don't need this anymore. And this would open up port 22 and port 80 to whatever, like, put in your IP address. And what I'd probably do is I'd probably go and construct a variable, that's like allowed IP address, allowed IPs, and it would be like a list type list string. And then in my terraform.tfrs, I would put in an array, and it would be 8. I guess we could, if we know that we only want to pass in /32s in the root module, we could make it allowed IPs and don't have to deal with that. And then what we would do is we would say, okay, so locals allowed ports, and that would be port 22 and port 80, right? And then we can say, okay, so then we could set up a new ingress rules that basically says, and so with this, we're basically iterating through the allowed ports and the allowed IPs, to construct the ingress rules for all of our allowed IPs on all of the ports that we want to allow. So that kind of cleans things up there as well. So security groups, I think I'm looking good. Looking at the instance, we're getting close to the end here. This looks a lot like a resource wrapper, so I'd probably just drop this in to the instance here. Okay, and then DNS is the last module that so I think with that we can put the nail in the coffin on instance, and then DNS is the last thing. And I mean, DNS might be one that we could refactor, or just leave, because I think it's a lot like the security group rule. So I think I'm okay with that in general. And it looks like they've kind of done something similar, or they're attempting something similar to what I've done with the security group rule, where we're not hard coding these DNS entries here. Example FML. Love it. That's funny. But I'm not going to analyze the syntax here, but I think the author's on the right direction here. I would just say simplify. Like if you can make this structure a little bit simpler, it's going to make your life a lot easier. Like, having nested object structures are tough. So try and avoid that, unless it actually makes things easier. Like in the case of this ingress rules, and make sure you have a separation of responsibilities between the reusable module and the client of the module. So in this case, all of this logic to construct these ingress rules, and I didn't even spell that right. is the responsibility of the client, of the consumer of that module. And then that module's life, this module is much more readable. We know exactly what's happening. There's less confusion, and it's more, it's more predictable, and it's easier to maintain. So yeah, and we could very easily throw on another, collection for egress rules, if we wanted to add that. I'm assuming that's like the other direction that you got on there. But yeah. So yeah, thanks a lot, Internet Stranger, for sharing your code and letting me dissect it in front of the whole World Wide Web here. Really appreciate it. This isn't Azure code. It's not using the Azure provider, but I think this is a good lesson in Terraform modularity. Like, what makes a good module? How do we design the interface between our modules and our reusable modules and the modules that are gonna that are gonna consume those reusable modules? Our root module. How's our root module gonna consume those reusable modules? And I think this lesson transcends any provider, and that's really the beauty and power of Terraform, is that these principles, these design principles, this way of thinking can carry. It's not just the code. It's not just the language. A lot of people just say, oh, well, the only thing you get with Terraform is that you can use the same language. But it's really, the structure, the mechanics, the design principles, of the modularity capabilities of Terraform, that are truly powerful, and will help you on whatever provider that you're using, whether it's Azure or OpenStack. So again, thank you to the Internet Stranger for letting me do this. And if you're working on something, and you want a code review like this, please send me your code. I'd love to do this. I think this would be a fun recurring series, like where I just dissect somebody's code from the wild. I think I'd benefit. Hopefully, the person who gives me their code is going to benefit. I'd love to clean it up. I'd love to approach it the way I approach it, and we can have a back and forth dialogue about different ways of doing things. So let me know what you think. Let me know if you've got code that you want me to look at. Would love to put it under a microscope and try and make it better. Anyways, that's it from me, from Azure Terraformer. Until next time, this is Azure Terraformer signing off.